नमस्कार मित्रांनो, today we are going to see average and RMS value for the sine wave. See here, this is the given sine wave which is having one cycle with the duration 2 pi. Okay, so it is spread from 0 to 2 pi and then new cycle will start. The maximum value for this cycle is Vm. We are considering voltage, that's why Vm. If you are considering current, then we have to take Im. Okay, and equation for this sine wave is V is equal to Vm sine theta. Now first of all we will find the average value for the voltage V average. According to the definition of average value, we have to consider the area under the curve, that is area under complete cycle over here divided by the base of that cycle. But as this is a symmetric cycle, okay, this is a symmetrical waveform, and that's why we will consider only half cycle, for which base will be pi. Okay, here we are considering only half cycle as it is a symmetrical waveform, therefore base will be pi, and therefore V average will be area. How to find area? By using the mathematical integration. Okay, so from 0 to pi we have to integrate this voltage equation and d theta, okay, divided by base, so it is pi. We are integrating v d theta from 0 to pi as we are considering half cycle divided by pi, and therefore this 1 by pi we will take constant 0 to pi Vm sine theta d theta, and this will give me Vm by pi integration of sine theta d theta. What is the integration of sine theta? It is minus cos theta. Okay, so this will be Vm by pi minus cos theta from 0 to pi. If I put the limits over here, what I will get? Vm by pi minus of cos pi, that will be minus 1, and next is minus minus will become plus cos of 0, that is 1. Okay, and therefore this will comes to be 2 Vm upon pi, or 0.637 into Vm. So V average is equal to 0.637 times Vm, or you can say V average is equal to 2 Vm upon pi. So this is the constant relation for sine wave between maximum voltage and average voltage. For the current we will get same thing. Here only I average will come, 2 Im by pi, or you can say I average is equal to 0.637 Im. Okay, now next part is how to find RMS value. So here I will consider now RMS value. So V RMS is equal to, again what we have to take? We have to take square root of squared half cycle. Okay, so 0 to pi V square d theta divided by base, that is pi. Okay, if I square both the side, I will get V square RMS is equal to 0 to pi. Now V will be Vm sine theta square d theta 1 upon pi. Got it? So what will be the next step? It will be 1 by pi. Vm is constant, so I will take Vm square out of that integration. Only 0 to pi sine square theta d theta. Now we can't integrate sine square theta directly. That's why we have to put the substitute of sine square theta as Vm square by pi 0 to pi 1 minus cos 2 theta by 2 d theta. So sine square theta is replaced by 1 minus cos 2 theta by 2 into d theta. So we have to integrate two different parts, 1 d theta and cos 2 theta into d theta. So these two I will take common, Vm square by 2 pi. Then what I will get? Integration of 1 d theta will be theta, then minus cos theta चा इंटिग्रेशन आहे sin 2 theta by 2 0 to pi. Okay, so by solving further, at the end what we will get? V square RMS is equal to Vm square by 2, and therefore VRMS is equal to Vm by root 2, or you can say 0.707 times Vm. VRMS is equal to 0.707 times Vm. So this is the relation between VRMS and Vm. This is the relation between V average and Vm. Okay, so now by using this value we have to define the two factors, that is form factor and peak factor. First, form factor. Form factor is nothing but RMS value divided by average value. So what is RMS value over here? 0.707 Vm divided by average value is 0.637 Vm. So this will give me 1.11. Second factor is peak factor. This is nothing but maximum divided by RMS. Okay, maximum value of voltage divided by RMS value of voltage. So maximum value is Vm, and RMS just we have solved is 0.707 times Vm. So this will give me 1.414. In next video we will see more numericals, only basic idea of that numerical, how to take this limits and what is the equation for that limit, that I will tell to you, and further you can solve it mathematically. Thank you.